Can you hear me, Jonica? If so, I don't know how to do this chat thing on this one. It's a little different for me. Oh, perfect. Okay. Let me just pull this up really quick and we can go over it. Did you do the quiz already or no? Okay, perfect. I can just kind of go through, and if you're taking notes or whatever, you can write down, excuse me, whatever you need to. No worries, I'll wait for you. I'm looking for mine still too. I've already taken it, so you can just watch it. Are you in yet or no? Okay, perfect. Okay, so for question number 3, this is the total area under normal distributions curve must equal what? I don't know if you've gone through the readings and stuff yet, but if you know the answer, type it in. If not, let me know too. No worries. Okay. So do you know the answer to number 3? Okay, so in the readings, it's pretty simple. It just states that the total area under the normal distribution curve, that it must equal 1. So the answer is just 1. Okay, so for number 4, under certain circumstances, a normal distribution curve can drop below the x-axis. This is false because a density curve always lies above or on the x-axis. I wonder if she can see like your comments, or if she just sees me talking to myself. Do you understand number 4? It's pretty simple. Yeah, for sure. I think I'm going to watch it after I post it. I got to figure out that step too, but I made it this far. I think I can do that. Yes, number 4 is false because the density curve has to lie on or above the x-axis. Can never be below. For number 5, a normal distribution is symmetric, which it pretty much gives you the answer in the question. Normal meaning even, so symmetrical. So true. Use the following images to answer the next 2 questions. Number 6, which of the following elements of the figure represents the z-score? So, Dina, how about you answer this one? Which one represents the z-score? Yeah, perfect. Okay, which of the following elements of the figure represents the probability that the z-score will be greater than 1.000? So it would be greater than z-score. Perfect. B. Okay, number 8. According to the 68, 95, 99.7 rule, what percentage of the data from the bell-shaped distribution will be within 1 standard deviation of the mean? So, so 1 standard deviation away from the mean would be what? Do you know? I don't know what your question mark is for. If you're asking if B was correct, yes, that is correct for the last one. Excuse me. Are you saying you don't know with your question mark, or what is that for? Are you still there, Jonica? Oh, sorry. Okay. So this one takes a little bit of math, like with the calculator, but it's not very hard. So it's just going to be 1 standard deviation away from the mean. So that'll be 68.27. Do you get how you get that one or no? Yes, that is the answer. So with the bell-shaped curve that it shows, excuse me, I don't know, just right above this it says to use for the next couple questions. So if you take, never mind, sorry, it has nothing to do with it. So it says, according to that rule, which we learned first week, what percentage of the data from the bell-shaped distribution will be within 1 standard deviation? So 1 standard deviation is, I wish I could draw on this thing. So you have like the, I can't actually. So if you have, yeah, so you use the table. So if you have like a symmetrical bell-shaped curve, you're going to have 1 standard deviation, the mean, and then another standard deviation. So if this is the mean right here, this is just like a normal symmetrical one. This will be 1 standard deviation. So 1, 2, 3, 4. So there's 4 standard deviations on this one, different for each chart. So it's just asking, what is it asking? So so we have 6, crap. So we have this right here. So we have 68, 95, and 99.7. So it's asking what percentage is in the first part of this 68. Do you kind of get it better now or no? Okay, yeah. So the first line for a symmetrical one is just 68. Mean is usually 95 unless it's like a left or right skewed one. And then the third standard deviation is 99.7. So between like 0 and the first standard deviation, it's asking what it is. So it's 68.27. Okay. I hope I'm not confusing you. I mean, I don't know this stuff super great, but I'm doing okay. Okay. So suppose that the z-score comes from a standard normal distribution. Use a normal probability applet to answer this question. What proportion of the z-score will be between -1 and 1? Do you know where to start with this guy or no? Do you know how to do this one, Jonica? It's supposed to be MVing this. I don't know what that means. I still don't know what you mean. It's all good. I won't make you think too hard. Okay, so for the z-score for number 9, it's just going to be 0.683. For number 10, it's the same thing. You just have to do -2 and 2 instead of -1 and 1. So it's going to be 0.955. And the same thing for number 11. It's -3 to 3, so it's just going to be a little bit larger. So it's going to be 0.997. So, sorry, going too fast. You can just tell me whichever one to go back to. So, tell me when you're ready so I can help explain this. There's nothing really to these answers. So number 9, so the only thing you have to look at is the -1 and the 1. So from -1 to 1, this is where the 68, 95, 99.7 rule comes in. So if it's -1 to 1, it's always going to be 0.683. That's where the 68 comes from. So number 9 is 0.683. And then so the same thing for -2 to 2 is going to be the 95 rule. So if you look at this, my super duper good drawing. So this is going to be 1 to -1. This is going to be 2 to -2. If that makes any sense, because you're going back 2 instead of just 1. When it gets 99.7, it's going to be going back 3 and forward 3. Does that make sense? No, it's not 99.7. That's like the rule we go by, but that's where that rule comes from. So it's going to be 0.997. So we're just leaving it raw. We're not moving the decimals anywhere. We're just leaving it as that number. Okay, so yeah. So number 9 is 0.683. You got that one? Okay, and then number 10 is 0.955. Okay, and then 11 is 0.997. Did you get those? Perfect. Okay. Okay, so I just answered this question for you. Number 12, the values that match 68, 95, 97. That's where that whole thing comes from, the whole rule or whatever you want to call it. Okay, for number 13, what proportion of the populations have protein requirements that is less than 60 grams per kilogram? There's the equation you use. And you just plug in the numbers into that equation, and you should get 0.238. You get that one, it's pretty simple. Okay, perfect. Same thing for number 14. And the answer is 0.762. For 16, same thing, just different numbers. It's going to be 0.525. So number 17 says 5 to 30, excuse me, find the 35th percentile for the protein requirement for adults. Round your answer to 3 decimal places. So you're on 15. Okay. Did you just say? Okay, where are you at? You're on 15? Sorry. I don't know how fast or slow to go because I'm not talking to you. It's hard to see. Okay. So what did you get for 15? 15 is 0.238. Yes. And then 14 is 0.762. Yes. And then 15 is 0.762. Same thing for both 14 and 15. That's probably where you got messed up. Perfect. Okay, and then 16 is 0.525. Just let me know when you get that one so I don't go too fast. Okay. 17, find the 35th percentile for the portion requirements for adults. So the same thing back to the 68, 95, 99. So 1 to negative, or negative 1 to 1 is the 68th percentile. So it's just going to be less than 1. So it's going to be so less than 68, I guess you could say. So 68 would equal 1. Less than 68 would equal, obviously, less than 1. That makes sense. So 35th percentile is going to be 0.623. Okay, and the 80th percentile is going to be 0.709. That should be it. Do you have any other questions? Did you get that last one? Do you get the last one, Jonica? Yeah, for sure. Yeah, sorry if I was going too fast or anything. I hope I helped you a little bit. If not, maybe next time when you have video chat, I can answer your questions better. Perfect. If you have any other questions, you can always text me or anything too. So, all right, I'm going to end this thing and then try and figure out how to post it. Thank you. You too.